Hello, my name's Adam Dunn. I'm a school teacher living in India, offering low-cost online tuition for the New Irish Project Maths, Leaving Certificate and Junior Certificate syllabuses. Today I'm going to talk about trigonometric functions. You're probably familiar with the definition of sine, cos and tan for angles less than 90 degrees. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. You're probably also familiar with Pythagoras' theorem, which states that the square of the hypotenuse is the sum of the squares on the other two sides. Now we look at two different triangles. One triangle has an angle of 90, 45 and 45 degrees, and if the isosceles sides are of length 1, the hypotenuse by Pythagoras' theorem must be of length the square root of 2. And then we can calculate sine 45, cos 45 and tan 45. Our second triangle is got by taking an equilateral triangle, that is a triangle with all sides 1, and splitting it down the middle, giving angles of 30 degrees and 60 degrees, and the bottom of length a half. From Pythagoras' theorem, the length of the perpendicular is then root 3 over 2, and now knowing the three sides, it's possible to calculate sine, cos and tan of 60 degrees and sine, cos and tan of 30 degrees. Now we're going to extend our definition of sine, cos and tan to angles greater than 90 degrees. A unit circle is a circle with centre at the origin and radius 1. We define the angle any radius makes with the positive direction of the x-axis as positive anti-clockwise. And finally we define cos theta to be the x value of the angle theta on the unit circle and sine theta to be the y value of the angle theta on the unit circle. When theta is less than 90 degrees, it's possible to see that our new definition of cos theta and our old definition of cos theta as adjacent over hypotenuse are the same thing. Similarly for sine theta, our new definition and our old definition are the same. Now when theta is over 90 degrees, we see something new, namely that cos theta is negative. Now in the first quadrant, cos theta is negative and sine theta is negative, which means that tan theta equal to sine theta over cos theta. Sorry, they're both positive. And tan theta equal to sine theta over cos theta is also positive. In the second quadrant, cos theta is negative and sine theta is positive, which means that tan theta equal to sine theta over cos theta is negative. In the third quadrant, sine theta is negative and cos theta is negative, which means that tan theta is positive. And in the fourth quadrant, sine theta is negative and cos theta is positive, which means that tan theta is also negative. Now let's plot sine, cos and tan of angles 30, 45 and 60 degrees, also extending our definition to angles greater than 90 degrees. We get the same lengths but different signs associated with them. Angles are done for all angles between 0 and 360 degrees. Using our points here, it's possible to plot the curve sine theta, and it has this form. Similarly, cos theta has this form. And lastly, tan theta, defined to be sine over cos, has this form. As I say, I'm a school teacher living in India. Because labour costs are so low here, it's possible for me to offer online tuition on a one-to-one basis at the rate of €15 per hour, with a free half-hour's introductory session to see if you're comfortable with my approach. Check out my website and email me if you're interested.